Hello, this is Xining Wang from Trinity College Dublin. Today, I'm going to give you a presentation as Neuroscience, Education, and COVID-19 Pandemic, Making Connections. So in the beginning of this presentation, I'm going to ask to play a game and answer me quickly and loudly what color you say in every word, not the word you read. So you ready? And what's the color you see this word? And what's the color of this word? And what's the color of this word? And please answer me, what's the color of this word? And this word? And this word? So thank you. And I'm sure some of you had made some mistakes. And this tricky game related to our brain function indeed. So thank you for your participation. And now I'm going to talk a serious topic, our brain function, education, and the COVID-19 pandemic. Recently, the interdisciplinary research between neuroscience and education is emerging as a growing field worldwide. Integrated educational neuroscience studies focus on, firstly, the function of brain. It has been seen as a biological organ that gives guidance to our behaviors, daily life, teaching, learning, and interaction. Secondly, neuroscience has tight connections with physical health, mental health, and the relevant psychology theories. With these theories, that's why neuroscience and psychology influence education. Thus, research in educational neuroscience is promising, and it provides fundamental findings in relation to brain function for educational practice. In order to understand how educational system, teaching, and learning have been working or not working, reducing the distance between the laboratory and the school environment, educational experiments could be designed to capture ongoing brain activity. Also, keeping pace with physical phenomena derived from brains that are engaged in interactive and realistic scenarios. On the other hand, the COVID-19 pandemic has led to extraordinary global crises and educational disruptions in recent years. For example, the shock of its disruption of global education is unprecedented. Nearly 1.6 billion learners cannot go to school. It covers more than 190 countries in the world. All students encounter the closures of schools and other physical learning settings, which account for 94% of the world's students' population, up to 99% in low and lower middle income countries. So there is an urgent need to reform the current understanding of education, especially teaching and learning. It is necessary to develop refreshed, expanded, innovative, and useful equipment to shape our educational practice and policies during the COVID-19 pandemic. We need a framework for it, and the framework of this equipment could be based on neuroscience. And more importantly, making this connection is now more relevant than ever. Now, I want to share with you a new discovery. It is basic mechanism of learning, which can begin to inform in an authentic manner curriculum, education policy, and everyday practice. Let's begin with a case study. It is a data-supported classroom experiment in relation to brain tests for interaction in teaching and learning activities by functional near-infrared spectroscopy, FNIRS. FNIRS is a non-invasive brain imaging technique that measures blood oxygen changes. Many neuroscientists have been using it and similar technology, such as EEG, for a range of educational experiments. For example, there are board game playing with brain test and musical instrument playing with brain test. As you can see from the pictures, it looks very funny, but it's experiment. And today's case study related to monitoring a teacher-student interaction experiment. Samples were females. One is a 4-year-old girl and another one is a 23-year-old teacher. In order to help the little girl's compliance with the FNIRS setup, reduce her panic, researcher has made a lovely fairy setting for her. She was told the experiment room would be a room of a spaceship. She has been chosen as a young astronaut. Her duty is to play a game while wearing a special helmet, just like the teachers. That's FNIRS cap. So in this game, the context is a space race. The teacher and the little girl hold 2 types of plastic pieces in different colors, yellow and blue. And the rule is that they need to move these pieces in a pathway marked with numbers. Then the winner needs to reach finishing lines as the first person with a bit calculating skills. As you can see, illustration of sources are red, dictators are blue, and channels grouped in 4 regions of their frontal cortex and the temporal parietal junction. Anybody knows why test prefrontal cortex and the temporal parietal of their brain? Because the prefrontal cortex is related to our high-order cognition, such as counting or calculating. The temporal parietal junction manages our social functions, such as empathy and mentalizing. So findings show that the signal of the child's brain activity was positively correlated with the teachers. Also, there is an evident correlation between the teacher and the child prefrontal cortex. These findings indicate the alignment of neural activity between the child and the teacher. And this alignment happened during their natural educational interaction. Demonstrating human brain activity in a classroom setting has been discussed for the long run. However, it has not been measured with in-classroom learning setting. So maybe in the future, we will see more neural educational experiments happen in a classroom. Therefore, neuroscience, the new dimension of our research and practice, it has potential constraints and springboards for acquiring higher human learning. For example, in Elon Musk's Neuralink project, with an implanted chip in the brain of a pig, then the pig's neural language could be read by a machine interface. Finally, today, coexisting with COVID-19 pandemic, neuroeducational studies help us to understand the cause of brain function, effective learning, learners with COVID-19 phobia, online learning anxiety, and other mental disorders. At the same time, it also questions us, how can we help them learn better? How can we design a quality curriculum for better teacher-student interaction, and how to tailor future policies in education to fit further COVID-19 related challenges. So this is today's presentation. If you have any questions, please feel free to leave a message or email me. And the case study is not from my research, it's not from our research, it's not from this conference. It is from a paper called From the Laboratory to the Classroom, the Potential of Functional Near-Infrared Spectroscopy in Educational Neuroscience. And thank you for participating in our conference. Thank you very much.